So these are the types of problems that we like, or I think that we like, because the denominators are already the same, right? So like this 2/13 plus 5/13. Well, we're already dealing with 13ths, so we're just going to take the two numerators and add those together, which are 2 and 5. Well, still dealing in 13ths here, but 2 plus 5 in the numerator gives us a new numerator of 7. And of course, at this point, we should be looking to simplify, but this one cannot be simplified, so that's just as far as we can go on that one. The next one, however, we'll see that this one can be simplified. Again, the denominator stays the same. We're looking at addition here. Let's take those two numerators, 2 and 5, and add them together, which when I do, it's not going to change the denominator, because remember, the denominator is the sizes of the pieces, but it will change the numerator. 2 plus 5 is 7. Now again, that's, well, maybe not again, but in any case, this can be simplified, okay? I know that 7 and 21 are both divisible by, well, 7. And it would have to be divisible by 7 because 7 itself is prime. So I'd have to divide 7 by 7, but remember, in order to not to change the value of this fraction, if you're going to divide the numerator by 7, you got to divide the denominator by 7 as well. So that's what I've done. 7 divided by 7 in the numerator is 1. In the denominator, 21 divided by 7 is 3. And this is again, this is pretty fairly simple for us right now. We should know right now what 21 divided by 7 is. If you need to use long division, it would just, I think it would add more work, but you'll get the same answer either way. And if you use long division, it's okay. Again, we've seen problems like this where this number is really big, and so we got to start doing long division for that. And if that happens, that's okay. So let's get on with subtraction here. And again, the nice thing about these first two is that the denominators right now are the same. So I'm going to keep the denominator the same here as 11. We are looking at subtraction of the two numerators, 6 and 2. Well, we're not going to change the denominator. The size of the pieces will still be the same, 11ths, but doing the 6 minus 2 there would give us 4. All right, now that's 4 11ths. And yeah, this one cannot be simplified. 4 is divisible by 2, but 11 is not, so that's as far as we can go on that one. And what about this next one? Well, the denominators are already the same. So it makes this very convenient. We are doing subtraction here between 15 and 9. So we're going to keep the denominator the same as 8 in size pieces of 8ths. 15 minus 9 is 6. So 6/8, we can see that these two numbers are even, which means they are both divisible by 2. So that's what I'm going to do next, is just divide these by 2, both in the numerator and denominator. I'm going to say this a lot, of course, but I don't feel like I can say it enough. If you do it to the numerator, in order to maintain the same value, you have to do it to the denominator as well, or vice versa. So 6 divided by 2 in the numerator is 3, and in the denominator, 8 divided by 2 is 4. 3/4, well, that cannot be simplified, which means that's as far as we can take this problem. All right, finding lowest common multiples. That's what this one wants from this problem. So I'm going to start with 45. I'm just going to list multiples of 45, and then, well, we'll see what they are, and then we'll list multiples of 24. If we can find a match in there, then that should be our lowest common multiple. If we don't find any matches, then we'll just have to extend the two lists. Okay. Of course, you're welcome to do this with prime factorization, but I'm going to use a list on this one. Okay. So if you do prime factorization, by the way, you'll get the same answer one way or the other. Okay. So remember, I'm putting check marks next to my multiples. 45 by itself is its own first multiple. So the next multiple would have to add 45 there. That's going to be 90. Got to carry the 1 there. That's our second multiple. Add another 45. That'd be 5 and 13. So that's 135 is our next multiple. Add another 45. 0, carry the 1. 4 and 4 is 8. 180. There's our next multiple. Add another 45. 0 plus 5 is 5. 8 plus 4 is 2. Carry the 1 is 12. 1 plus 1 is 2. 225. So that's, what do we got there? 1, 2, 3, 4, 5. 5 multiples. And I'll stop right there for now, even though we may need to make that list bigger. But let's look at multiples of 24, which again, itself is its own first multiple. So let's go and add another 24 to that. That'd be 48. Just a quick check. I don't see any matches, so we'll keep going. Add another 24. Not 48. 8 plus 4 is 2. Carry the 1. 1 plus 4 is 5. Plus 2 is 7. 72. Yeah, still no matches. So another 24. 2 plus 4 is 6. 7 plus 2 is 9. 96. Yeah, still no match. So another 24. There's a 0. Carry the 1. 10, 12, 120. Oh, I was thinking of 180 was close. So let's keep going with multiples of 24. Plus 24 there. 0 plus 4 is 4. 2 plus 2 is 4. And then drop the 1. 144. Yeah, still no matches. Let's add another 24 then. 4 plus 4 is 8. 4 plus 2 is 6. Drop the 1. 168. No matches still. Add another 24 then. 8 plus 4 is 2. 12. Carry the 1. 1 plus 6 is 7. Plus the 2 is 9. 192. Yeah, still no matches. So let's keep going. Add another 24. There's a 6. 9 plus 2 is 11. 216. Now, I mean, that's two pretty good lists. However, I still don't see any matches. So let's keep going on this. In fact, I'm gonna continue with the 24s. All right, since I'm already on a roll with those 24s. So another 24, 6 and 4, 10. Carry the 1. 1 plus 1 is 2. Plus 2 is 4. 240. Another 24. Well, I know that writing is getting small because I'm running out of space there. Hope that's okay. 4 plus 2 is 6. 2. Add another 24. Now, by the way, the reason why I'm continuing past 240 here specifically is because I know all the multiples of 45 have to either end in 5 or 0, which we've seen in this list so far. So I need to see other values, other multiples of 24 that end in 0 or 5. Of course, we won't see any that end in 5, but certainly 0. So let's keep going. Let's see. There's an 8. 6 plus 2 is 8. 288. Add another 24. It's not going to get us there either. 1 plus 8 is 9. Plus 2 is 11. So that's 312. I'm not going to make it. I need more space. There's a 6, 3, and a 3. So I'm going to have to continue this list up and to the right from 336 right there, which was our next multiple. I forgot to put a check mark next to that, though. Let's go back and do that. How many of these are we going to go through? I don't know. I don't have my multiples of 24 and 45 down well enough to say. There we go. So we're back to 336, right? So let's go ahead and add another 24 there. So that's a 0. Carry the 1. 1 plus 3 is 4. Plus 2 is 6. 360. Now that one ends in 0, so I'm going to stop there. But let's continue with the multiples of 45 and see if we can get up to 360. And I think we will. Let's find out for sure. So add another 45 there. 5 plus 5 is 0. Carry the 1. 1 plus 2 is 3. Plus 4 is 7. 270. Another 45. 5. 7 plus 4 is 11. Carry the 1. 1 plus 2 is 3. 315. Add another 45. There's a 10. 1 plus 1 is 2. Plus 4 is 6. 360. There we go. Good. We found it. I mean, there's quite a bit of work with those multiples of 24, but we found it. 360. Whoops, not crossed out. Highlight it. There we go. 360. Okay. So the lowest common multiple between these two numbers, 45 and 24, is 360. Now, of course, you may be thinking, well, perhaps the prime factorization way would have been faster, and it could have been. But it depends on your preference, right? Would you prefer to factor these and then find your greatest common factor and then the non-common factors multiplying, or do you prefer to just multiply or just add the numbers like we've done here? So it doesn't matter if you feel like it's easiest. Well, no, it does for you, but for other people, yeah, perhaps factoring may be easier or this method. But yeah, two solid methods and you'll come up with the same answer either way. So find the lowest common denominator of these two fractions. Now, since it's only asking about the denominator, we don't really need to worry about the numerators, which, by the way, we're not operating with these fractions either. So hopefully that becomes at least slightly clear. You know what I'm saying? So let's look. Let's look at 12 and 18. So I'm going to list multiples of 12 and 18. Or you know what? We did multiples on that last one, so I'm going to use the prime factorization on this one. Okay? Hope that's okay. So I'm going to split 12 and 18 up separately, okay, into their prime factors. Now again, if you made a list of these two values, you'd find that it works exactly the same way, right? So I'd say 12, I'm going to say between 3 and 4, right there, and 3 is prime, and then 4 splits up into 2 and 2. All right? So with that, let's go ahead and list 12 here as a product of its prime factors. 3 times 2 times 2. And then let's go to 18. Now on purpose, I know 18 is divisible by 3. Let's just make the list line up pretty well. But 3 and 6. And then 6 would be multiples of 2 and 3, which are both prime. So now let's list the multiples, or the prime factors rather, of 18, which are 3, 2, and 3. Now what we do want on this one is the greatest common factor first. And we're going to find the greatest common factor, and then whatever it is, we multiply it by the other non-common factor. So I'd see this pair of 3's right there, which are common factors. So there's a 3 that's a common factor. And then this set of 2's also are common factors. Now, since they are factors, we're going to multiply these. 3 times 2 is 6. So the greatest common factor between 12 and 18 is 6. But remember, if I want the lowest common denominator, which we do in this case, lowest common denominator, you got to take the greatest common factor, which is 6, and then we also had this 2 in purple that was not a common factor. I'm going to have to multiply that by the 6. And then the 3 also in green there, that's not a common factor. It needs to be multiplied as well. Okay, so we end up with 6 times 2 times 3. And I'm just going to do this from left to right. That's not too bad. 6 times 2 is 12, and then multiply that by 3. 12 times 3 we know, or should know, is 36. So the lowest common denominator to use would have been 36. And so again, you would have found the same exact answer here, even if you had made a list of multiples of 12 and 18. 36 is the second multiple of 18 and the third multiple of 12. So perhaps I did do this in the longer way. But again, it doesn't matter how long it takes. It just matters if you prefer it or not. Okay. So 5/4 plus 2/3. Yeah, let's go ahead and operate on this. And yeah, now we're adding, but the denominators don't match, right? So we're going to have to force the denominators to match. And 4 and 3 are, I'd say these are small values. So, I don't know. You could list them if you want. I'm just going to multiply them by each other, right? So I'm going to take the 4 multiple denominator and multiply it by the numerator and the denominator of the other fraction. So that's my second fraction. The numerator 2 times 4 is 8. The denominator 3 times 4 is 12. So I'm going to take the 3 denominator and multiply it by the numerator and denominator of the first fraction, multiplying by the numerator 5 and the denominator 4. So in the numerator, 5 times 3 is 15. And in the denominator, 4 times 3 is 12. So we're going to add these together. Let's see what we get out of that with the denominator of 12. We're adding 15 rather. 15 and 8. So keeping that denominator of 12, 15 plus 8, I get 23. Now if this could be simplified, we would, and there's nothing in this problem to indicate that it wanted the answer as a mixed number. So I'm just going to keep it as an improper fraction. Not only does that save us time and work, but, well, I think it's easier. Plus, just by having to change these into mixed numbers, it does add an extra step. While it's not so common that we see a lot of mistakes in that step, it just happens from time to time. And, we don't want to rob you of any credit like that. So This one didn't say anything about mixed numbers or improper fractions. Let's just keep it as an improper fraction. 3/11 plus 5. Now I'm going to do this what I feel like is the long way, but there's kind of a quick shortcut to this, um, but I'll show it afterwards. All right. So 3/11 plus 5. Well, that's really 5 over 1 right there, just so we can see the denominator, so we can add the two fractions together. We need the denominators to match, and again, since one of the denominators is 1, I'm just going to multiply it by the denominator of the other fraction, right? So that'd be 11. But in order to not change the value of that fraction, I'm going to have to multiply the numerator also by 11. So I did not do anything to the 3/11. It's going to stay 3/11. But I did do something to that second fraction, the 5/1. 5 times 11 is 55. In the denominator, 1 times 11 is 11. So that gives us a common denominator of 11, which is good. It's going to make it simple enough for us. The first numerator was 3. The second one was 55. We just need to add these together. Oh, that's going to come out pretty good. So it's still out of 11, but adding those two values, 3 and 55, would be 58. And I hope it's okay that I don't show the stacked addition on that. Oh, well, I thought that was going to simplify. It does not, because 11 is prime and 58 is not divisible by 11. Again, no need to change this into a mixed number. I mean, you're welcome to. Looks like that'd be 5 and 3/11, but no need to do that if we can stop right there. And we have denominators of 10 and 12, so we're going to have common denominators there. So let's see. Let's just multiply the denominators by each other again. So this denominator 10, I'll multiply it by the 12 and the 5. Okay, so that's going to change that fraction. Oh, I put 12 there. What the heck? I meant 10. That's better. All right, so the denominator, 12 times 10, would be 120. The numerator, 5 times 10, is 50. And then the 12 denominator, I'll multiply it by the numerator and denominator of the first fraction. 3 times 12 is 36. 10 times 12 is 120. And then we see those matching denominators just like we needed, which then will allow us to just add the numerators. But the denominator will stay the same as 120. So we got 36 plus 50. And again, this step, eventually you'll be like, I don't really need to see or do that step, and that would be fine. But I'm going to show it because, it still may be helping some people. So 36 and 50. Let's go and add these together. 6 plus 0 is 6. 3 plus 5 is 8. 86. All right, so looking at this, they're at least divisible by 2. I can't really think of anything else that it is divisible by. Let's find out, though. All right. So let's go ahead and divide both of these by 2, and then see if that new fraction will be even further simplifiable. So let's see, 86 divided by 2, that's a 6. 2 goes in 8 4 times, so that would subtract 8 there. Drop the 6. 2 goes into 6 3 times, 43. So that's our new numerator. Let's do 120 as well. Divided by 2. 2 doesn't go into 1, but it will go into 12 6 times. 6 times 2 is 12, so that zeroed that out. 2 goes into 0 0 times. So 43 60ths. 43 is not divisible by 3, while 60 is. So it's not divisible by 6 either. It's not divisible by 5 or 2 or 10. So yeah, that looks like it's about as simplified as we can make that answer right there. 43 60ths. So again, that really just took care of that last step. Make sure you're checking to see if those fractions that you get once they're proper, improper, or mixed numbers, just make sure that they cannot be further simplified after that. Now we're moving on to subtraction, though. Okay. So again, we need the denominators to match again. So let's look at this. 2/9 minus 1/7. And let's just stick with that method. It seemed like it was the preferred method to just multiply the denominators by the other fraction. So the 9 denominator, I'll multiply into the second fraction in both the numerator and the denominator. So that gives us a new fraction there. 7 times 9 in the denominator is 63. And in the numerator, 1 times 9, that's good multiplication. Because the identity property of multiplication is 9. But the 7, the denominator of that second fraction, I got to multiply it by the denominator and numerator of the first fraction. So again, that'll change our denominator automatically into 63, so they match, which is what we want. But the numerator, 2 times 7 is 14. So yeah, that accomplishes our first goal to make the denominators the same. So let's go ahead and subtract those two numerators, 14, and we'll have to subtract that 9 right there. So 14 minus 9, let's see what that gives us. Still 63rd size pieces, but 14 minus 9, I get 5. 5 63rds, and 5 is prime. 63 is not divisible by 5, so that completes this problem. All right, simplify these two. Subtract these two, and then we'll simplify if we need to. I'm not gonna multiply the denominators by each other for the simple fact that they're kind of big numbers. So I'm gonna list them out, and we're gonna see that the list will be kind of the better method on this one, anyways. So let's look at multiples of 12, right? 12, 24, 36, 48, 60. We'll go that far for now. Let's look at multiples of 18. Of course, 18 is its own first multiple. We don't have these memorized, so let's add 18 to 18. There's 16. 1 plus 1 is 2, plus 1 is 3. 36. Boom, we found it. All right, so our common denominator here is 36. So let's go ahead and rewrite these two fractions with denominators of 36. But we got to figure out what those numerators are. Well, what do we have to multiply those denominators by to make them 36? Well, I can see 12. That 36 is its third multiple, so I'd have to multiply it by 3, which means I also would need to multiply 17 by 3 as well. So let's do that multiplication. We'll stack it. 17 times 3. Some of you have this down and can do it pretty quick, and that's good. 7 times 3 is 21. Carry the 2. 3 times 1 is 3, but add the 2 makes that 5. 51. So that'd be 51 36ths in the first fraction. And then in the second fraction, the 18, I can see that's the second multiple of 18 36s. So I'd have to multiply the 18 by 2, which means I also need to multiply the 7 by 2 as well. And we got that one down. 2 times 7 is 14. So the denominators match. That's good. That's exactly what we want. We're going to rewrite this with the common denominator of 36, but we're going to subtract those two numbers, 51 and 14. So let's stack these and subtract them. 51 minus 14. What do we get? 1 minus 4, we're going to have to borrow from the 5. 11 minus 4 is 7. 4 minus 1 is 3, 37. So here we see another improper fraction because the numerator is bigger than the denominator. But again, it didn't specify that it wanted the answer as a mixed number. So yeah, we're going to keep this as an improper fraction. Well, even though it's a whole number minus a fraction, we're still going to need a common denominator on this one. And the whole numbers, like the 6 there, of course, we look as 6 over 1, because it really is dividing by a phantom 1 right there. And so let's, now that we have that as a fraction, let's go ahead and force the denominators to be the same. Of course, we're still dealing with subtraction. That's okay. Yep. So since the one denominator is just 1, I'm just going to multiply it by 5 and the 6 by 5. And that will force the denominators to match as 5. So that's the denominator there, 1 times 5. In the numerator, 6 times 5, which is 30. So 35ths, yeah, that equals 6. And that second fraction, of course, we're not really doing anything with, because the denominator was already 5. So forcing the denominators to be 5, let's go ahead and operate in the numerators. 30 minus 3. And, well, we can go ahead and stack that, show that subtraction there. 30 minus the 3. So the 0, we'll have to make that 10 to borrow from the 2. 10 minus 3 is 7. Drop the 2, 27. So we get 27 fifths, and that's okay to have improper fraction right now. We shouldn't need a mixed number on that, so that's good. So now that we're looking at mixed numbers being operated on, that means that if we have an answer that's a improper fraction, then we'll need to change that into a mixed number. So that's going to happen on problems like this one. So I'm going to show both answers for this, but again, when you look at the quiz for these types of questions, it's going to want the answer as a mixed number. So first thing for me is to change these two numbers into improper fractions using cycle method, right? So that'd be cycle method on the 2 3/5, so that'd be 2 times 5, which is 10. And then add the numerator 3 to make that numerator 13. Of course, the denominator stays the same. And we can see that the denominators match, so this is going to be a fairly nice one for us. And in the second mixed number, 7 times 5, right, using some cycle method there, that's 35, and then add the 1 numerator to make that 36. So that's a 36 numerator with a denominator of 5. Okay, so the denominators match, so there's no need to force the denominators to be the same. They are already the same, which means we can start operating with the numerators. 13 plus 36. So we'll stack those and add them just below 13 and 36. Let's go and add those two together. Add. 3 plus 6 is 9. 1 plus 3 is 4. 49. So, with the problems we were just doing with just fractions, this would be good enough to show 49/5. But, again, on the quiz, it's going to want these answers as mixed numbers, okay? So let's go and do the long division on this, and some of you don't really need to do it, but if you do, then hopefully this helps. So I'd say, well, 5 won't go into 4, but it will go into 49. Well, 9 times. 9 times 5 is 45, and yeah, we do expect you to have that memorized by now. And whatever I get from this subtraction will be my remainder. 9 minus 5 is 4, and the 4's zero out. So I have a quotient of 9, a remainder of 4, and that's important because, remember, the mixed number will keep the denominator the same as 5. The quotient here is 9, so that's our whole value of the mixed number. And then the remainder was 4, that's going to be our numerator. So 9 and 4/5, that would be our final answer there. More addition, and again, we got the mixed numbers, so we're going to have to change these into improper fractions first, and then we'll worry about the operation, which is addition. So let's set up our two improper fractions here with some addition. Maybe I should have made that smaller, but let's go and cycle method this. 12 times 10, that's 120. It's just a 12 with a 0 tacked on then, right? Multiplying by 10. And then add the 3 numerator to make that 123. So that's our new numerator, 123 of the first fraction. Again, the denominators do not change, so that second denominator will automatically be 6, even with cycle method. Cycle method will only change the numerator, right? So the second fraction, we got 5 times 6, which is 30. And then add the 1 numerator, so that's 31. 31/6. Okay, so these two fractions, it's nice. They have mixed number. We've changed the mixed numbers into improper fractions. That's what we want. But what we need next is for the denominators to match because they don't. So, you know what? The lists aren't going to be too bad on this one. So for those of you that like the list on this one, that's what I'm going to do. Of course, you can multiply the denominators into the other fractions. You'll get the same answer eventually, but in the meantime, they may look a little different. Okay, so we're going to still end up with two fractions being added together here. But let's go and look at multiples of 10. So 10, 20, 30, 40, 50. And yes, I went past the common denominator on purpose so that everyone can see it. Multiples of 6, 6, 12, 18, 24, 30. And so I'll stop there at 30. We can see that 30 is our common denominator that we can use. So I'll write those in right now, even though we're going to still do the operation. The scaling of the fractions to force the denominators to be the same. So starting with the denominator of 10, I can see that 30 is the third multiple of 10, which means I'd have to multiply it by 3. So I'd have to multiply the 123 by 3 as well. and that would be my new numerator. So 123 times 3. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. 369, so that's my new numerator there. And then our second denominator is 6. 30 here is the fifth multiple of 6. So I'd have to multiply the 6 by 5 to get this 30 in orange, but I have to multiply the 31 by 5 as well. So let's do that stacked multiplication there. 31 times 5. 5 times 1 is 5. 3 times 5 is 15. 155. So that's a pretty good setup so far. We just need to add those two numerators together because now the denominators match. So we're going to keep the denominator as 30, but we need to add those two numerators, 369 and also 155. So let's go and add those together. 369 plus 155. And this will give us the sum, which is our new numerator of the simplified fraction there. Still in 30th, so let's go and add these together. 9 plus 5 is 14, carry the 1. 6 plus 1 is 7, plus 5 is 12. Carry that 1. 1 plus 3 is 4, plus 1 is 5. 524. So 524 thirtieths, I can see that, well, let's see, 524 is not divisible by 3, but it is at least divisible by 2. So let's go ahead and do that. Let's simplify this by 2. Now, I'm not changing this into a mixed number yet, although our final answer should be in as a mixed number. So 524, let's go ahead and divide that by 2, and then 30 divided by 2 as well. 524 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. Subtract 5 minus 4 is 1. Drop the 2 to make it 12. 2 goes into 12 6 times. 6 times 2 is 12, so that zeroes out. Drop the 4. 2 goes into 4 2 times. So our new numerator is 262. Where we have our denominator, though, 30 divided by 2. 2 goes into 3 once. 1 times 2 is 2. Drop the 0 to make it 10. 2 goes into 10 5 times. So it's our new denominator, 15. 15 is divisible by 3 and 5, but 262 is not divisible by either of those. So that is our final improper fraction. But, like I said, if we see that the question starts with a mixed number, generally speaking, then we need the answer also to be a mixed number. So we'll check the fraction in the mixed number to just make sure that it's fully simplified in the end. But if we've done our job right here, then it should be pretty good. So I'm going to keep the denominator the same as 15, but I need to do some long division between the 262 and the 15. All right, so let's see what we're going to need on this. Well, we might need a little bit, but 15 won't go into 2. It will go into 26 only once. 1 times 15 is 15. 6 minus 5 is 1. 2 minus 1 is 1. So I'm going to drop this 2. So this is where it may be helpful to see a list of multiples of 15. 15. I'm gonna skip the addition on this. I hope that's okay, just to save us a little bit of time on that. 75, 90, 105, and then 120. So there's our multiples of 15, and the one next to 112 just lowest than it is 105 there. So that's 1, 2, 3, 4, 5, 6, 7. That's our seventh multiple of 15. 7 times 15, yeah, that's the 105 there. So minus the 105. And this will give us a remainder. 2 minus 5, we'll just have to borrow from 1 to make it 12. Minus 5 is 7. And then the tens and hundreds place zeros out there. So in our mixed number, we have the quotient from the long division, which is 17. And then the remainder, which is 7, that'll be our numerator. And yes, looks like we simplified that very well because the fractional part of our mixed number cannot be simplified. So that's it. Well, for now, we got two mixed numbers added together, 9 and 5/8 plus 7 and 5/8. So since these have mixed numbers in the original problem, we're going to want to change our final answer into a mixed number, just like it will on the quiz. And yeah, our first step on this one is to use cycle method in order to change these into their improper fractions, and the denominators will not change. And they already match, by the way, so that helps us out. That makes this very convenient. So I'm going to cycle method on the 9 and 5/8 there. 9 times 8 is 72. Add the numerator 5 to get 77. Okay. So I am probably not showing as much work as you'd like on this one, or most of these, just because, again, we're just kind of pressed for time on this. Okay. So 77/8 is that first fraction, the improper fraction, but I got to do the second one as well. 7 times 8 is 56. And then add the numerator 5 there to get 61. There was a 1 carried over. So that's 61/8. So 77/8 plus 61/8. Yeah, we can change this into a full one improper fraction by taking the 77 and adding the 61. So let's see, what do we get when we take the 77 and add the 61? 138, that's what I got. So we just need to write this in then as a fraction. The denominator is 8 still, of course. But yeah, just like we found, 77 plus 61 is 138. Now, I would look to see if this can be simplified, and since they both end in 8, these both are certainly divisible by 2. Let's go ahead and divide these by 2 and see what we get after this is simplified. 8 divided by 2 is 4. That's the easy one, but still need to do the 138 divided by 2. So 2 won't go into 1, but it will go into 13. 6 times 2 is 12. Subtract. That's 1. Drop to 8 to make it 18. 2 goes into 18 9 times. 9 times 2 is 18. Yeah, so that cancels that out. Nothing remaining. So we have 69/4. I do not see that can be simplified, except that we just want the answer as a mixed number. So that's what we're going to do. Of course, the denominator will still be in fourths, but I need to perform this division, long division. 69 divided by 4. And 4 goes into 6 once. 1 times 4 is 4. Subtract 2. Drop to 9, 29. 4 goes into 29 7 times. 7 times 4 is 28. And the subtraction here is going to give me the remainder, which is 1. So the quotient, 17, that's our whole value, and then the remainder 1 is the numerator. 17 and 1/4. Well, that'll do it. So here's our next one. We're adding, again, we got mixed numbers, and now the denominators are not the same, but that's not a problem for us. We can still operate with these. First things first is to change these two mixed numbers into improper fractions. So let's start with that. Of course, the denominators won't change. It'll still be a 9 and a 6 there. Cycle method now. So first up, I got 10 times 9, which is 90, and add the 4 numerator. Give us 94. So 94/9 first, plus 11 5 6. So first cycle method, 11 times 6 is 66, plus the 5 to give us 71. Carry the 1 over there. So that ends up being 71/6. The denominators do not match, so we need to force them to match. And while you could multiply them together, I think making a list of their multiples will be just a little faster. And since we're looking to kind of speed things up a little bit today, that's what I'm going to do. Multiples of 9, 9 and 18. I know 18 is a multiple of 6. Well, which multiple is it? 6, 12, 18. It's the third multiple there. So I'm going to change our denominators into 18. Well, how do I do that? It means I got to scale these other fractions up. 18 is the second multiple of 9, so I'm going to have to multiply the 94 by 2 as well. So that'd be 94 times 2, which is 8, and then 18, 188. And the 6, that's the third multiple. To make that denominator 18, so I got to multiply the 71 by 3 as well. 71 times 3, 213. Okay, I'm doing that kind of fast just because, well, I think we're going to need the time. So now we have the denominators matching is 18 We just need to add the two numerators together, which was 188 and 213. All right, from this addition, 8 plus 3 is 1, 11 really. Carry the 1, 1 plus 8 is 9, plus 1 is 10. Carry that 1, 1 plus 1 is 2, plus 2 is 4, 401. So our new fraction in 18th is 401, 18th. All right, well, 18 is divisible by 3, 401 is not. It's divisible by 2, but 401 is not. So it looks like 401 18ths would be our simplified improper fraction, but we started our question out with mixed numbers, so we're going to need to change this into a mixed number. Let's go and do that. We'll do the long division below. I'll give myself a little bit more space though. 401 divided by 18. Well, in the mixed number, by the way, the denominator is not going to change. It'll still be an 18. You just got to figure out the whole value in the numerator there. And I do not know my multiples of 18, so I'm going to have to list those off to the side. 18, the next one is 36. I'm kind of skipping the addition here for purposes of time. That's strictly purposes of time. 90. I'll start with the fifth multiple. Let's see if that's enough. 18 will go into 4. It will not go into 4, but it will go into 42 times. 2 times 18 is 36. Subtract, I'll have to borrow from 4 there. 10 minus 6 is 4. The 3 is 0 out. 41. Well, that's good. So 18 goes into 41 another 2 times. 2 times 18, still 36. When I subtract, that will give me my remainder of 5. So, going back to our problem, the quotient there that I haven't read, 22, that's our whole value, and then the remainder of 5 is the numerator of the mixed number. And then, of course, last thing you should do is check to see if this fraction can be simplified. I do not see that it can, so that's complete. So, still subtracting now with our mixed numbers, but now the denominators don't match, and that's okay if they don't match, but so enough space. Hopefully that's enough space. Let's find out. All right, so let's change these into improper fractions first with cycle method. Okay, so 5 times 15. I'm not going to worry about showing the stacked multiplication on that. 75, and then add the numerator 11 to make that 86. That first fraction is 86 15ths. And then the second fraction with cycle method, 3 times 6 is 18. Add the 1, makes it 19. So that is 19/6 as the second fraction. And again, you can multiply those two denominators by each other. Again, I'm going to take what I feel like is the shorter method just for the sake of time and list the values out, because 15 is its own first multiple. 15 plus 15 is 30, and 30 is a multiple of 6. Well, which multiple is it? Let's find out. 6, 12, 18, 24, 30. Boom. So we're going to change these two fractions into two fractions that have the same value, but now the denominators are 30 and 30. They match, which is what we want. So in green there is the 15, right? That's the second multiple of 15, so I'd have to multiply it by 2 to get that green 30 denominator. So I'd have to multiply the 86 by 2 as well. So I'm going to stack this multiplication and do it though. 86 times 2, 2 times 6 is 12, carry the 1. 2 times 8 is 16, but plus the 1 makes that 17. So 172 30ths. And then 30 is the fifth multiple of 6, so 6 times 5 would make that orange 30 denominator. So I'd have to multiply the 19 by 5 as well. And it's not difficult multiplication, so we can show it. 9 times 5 is 45, carry the 4. 5 times 1 is 5, add the 4 is 995. So I have 172 30ths minus 95 30ths. And yeah, I'm going to continue to show this step. Still in 30ths, but we're going to subtract these two numerators rather. 172 minus 95. All right, so 2 minus 5 in the ones place value, you got to borrow from the 7. 12 minus 5 is 7. And so that's going to be 16 minus 9 there, which is 7. Again, 77. So that would be our numerator in 30ths, 77 30ths. There, and I do not see that this can be simplified. 77 is divisible by 7 and 11, but 30 is divisible by neither of those. So that means we're going to go straight into changing this improper fraction into a mixed number. Of course, the denominator stays the same as 30th. So let's show the long division just below this. 77 divided by 30, and we don't even need that many multiples of 30. 30, 60, 90. I'll stop there because that's all we need. 30 won't go into 7, but it will go into 77, those 2 times that we have. 2 times 30, we can see there's 60 there. When I subtract this, will give me my remainder. 7 minus 0 is 7. 7 minus 6 is 1. 17 is the remainder. So our quotient 2 is the whole value. The remainder is the numerator of 17. 2 and 17 30ths, that's our final answer. Subtraction of mixed numbers. So the process doesn't change for us, of course. We're just going to use it on different values, that's all. So whatever we get out of this is going to be 2 improper fractions, and still using subtraction here. Let's go ahead and do some cycle method on these. 12 times 7, 84. And add the 5 numerator there to get 89. So that's 89 sevenths. And that second fraction will have a denominator of 35. So I'm just going to write that in now, if I can do it correctly. And then down here we got 5 times 35. And I'm going to kind of skip that into 175, it looks like. And then add the 4 numerator to get 179. Just trying to save some time today, so that'd be 179 35ths. So again, I got the 175 first from the 5 times 35, and then adding the 4 gives that 179. So I can see that the denominators do not match, but we need them to match, right? Now, for all the methods we have, the method that's going to work best on this one is to see that 35 is already a multiple of 7, which means that I have no need to change that second fraction. It can still be 179 35ths. And here's what I mean by that is 35 is a multiple of 7. Well, which multiple is it of 7? It's the fifth multiple of 7. So I'd multiply the 7 by 5 to make that denominator 35. See, that matches? But I have to multiply the 89 by 5 as well. So let's see what that gives us. 89 times 5. 5 times 9 is 45. Carry the 4. 5 times 8 is 40, but add the 4 makes that 44. So 445 35ths. And again, we only had to change that one fraction because we saw pretty quickly that the second denominator was a multiple of the first denominator. So now that the denominators match, we can subtract these. 445 minus 179. So let's stack these and see what we get. All right, 5 I'll have to borrow from the 4. 15 minus 9 is 6. 3 I'll have to borrow from that 4 as well. 13 minus 7 is also 6. 3 minus 1 is 2. 266. So this ends up being 266 35ths. Let's see. 35 is divisible by 5 and 7 only. 266 not divisible by 5, but is it divisible by 7? Oh, it is. Okay, well, that's simplifiable by 7. That means we take 35 and divide it by 7, and 266 by 7 as well. That will simplify this fraction for us. 35 divided by 7 is 5. And then when we take 266 and divide it by 7, we should get a whole value here. Let's find out. 7 will not go into 2, but it will go into 26 3 times. 3 times 7 is 21. 6 times 1 is 5. Drop 6. 7 goes into 56 8 times. So yeah, that cancels that out and makes this 38 fifths as a more simplified fraction. That cannot be simplified any further. So let's go ahead and change this into a mixed number. course, the denominator will still be in fifths, but we got to take the 38 and divide it by 5. So what do we get? 5 will not go into 3, but we're going to 38 7 times. 7 times 5 is 35. We're already dealing in the one space value, so this is the remainder of 3. The whole value is 7. The numerator is 37 and 3/5. Yeah, that's simplified. There we go. No worries, we can do subtraction with these mixed numbers. Well, just like usual, let's go and apply our cycle method on these. First the 9 and 1/4, so that'll give us some number of fourths. Same with the other fraction as well, right? That's going to be in fourths as well. So cycle method, 9 times 4 is 36, and the 1 there is 37. So 37 fourths from the first fraction, the second fraction, 6 times 4 is 24, and the 3 to make that 27. 27 fourths on the second fraction. Now we're ready, the denominators match already, so we are ready to subtract the numerators. 37 minus 27. A little quick math for us today, just for the sake of time. 37 minus 27 is 10. And so the 10 fourths can be simplified. These are both divisible by 2. And 10 divided by 2 is 5. 4 divided by 2 is 2. So that's our improper fraction. Since we started with mixed numbers, we need to change this into a mixed number. So the denominator will stay 2. Let's go and do our long division down here. 5 divided by 2. 2 goes into 5 4 times. Sorry, 2 times. Add that backwards. 2 times 2 is 4. So that gives us the remainder of 1. So the quotient is 2. The remainder is 1. 2 and 1/2. Done. That was nice. I like these when the when the denominators match. It makes it pretty convenient for us. All right, more subtraction. Well, more subtraction is not more problems, just more work. All right, cycle method on 11 and 1/6. Just 11 times 6 there first. So 66. Add the 1. That's 67. So that first fraction in 6 would be 67 6. Of course, we still need to subtract the other mixed number, and yeah, the denominators stay the same as fourths there. That'd be 7 times 4 for the numerator is 28 plus the 3 makes that 31. So 31 fourths, 67 sixths minus 31 fourths. Now let's go ahead and change the denominators so that they're the same, or force them to be the same at least. So I'm going to make a list on this one. You don't have to. You can multiply them. Again, it's more important that the answers are the same than the method that you use. So I'd say, well, multiples of 6, 6 and 12. I know 12 is a multiple of 4. 4, 8, 12. See that? So I can see I can make the denominators match as 12s, but I got to scale the numerators simultaneously. So 6, that'd be 6 times 2 to give this 12 in green. So 67 times 2 as well. $134. And then 12 here is the third multiple of 4. So 4 times 3 gives us the orange 12. 31 times 3. 1 times 3 is 3. 3 times 3 is 9. 93. 93 12. So that's good. Now that the denominators match, we're ready to subtract the two numerators, which is 134 and also 93. So let's go ahead and subtract those out. 4 minus 3 is 1. 13 minus 9 is 4. 41 is our new numerator. Still a denominator of 12, though. 41 12. 41 is not divisible by 3 or 2, which is all 12 is divisible by that we need. So, yeah, we can't actually simplify that. So we just need to change it back into a mixed number, 12. So we'll do 41 divided by 12. 12 goes into 41. Looks like 3 times 12 is 36. When I subtract this, I get 5 because of the borrowing. So that's my remainder. The quotient is 3, the remainder is 5, 3 and 5/12. That's complete. So a chewy fruit recipe calls for 6 3/8 cups of brown sugar and 5 4/5 cups of white sugar. How much sugar is needed to make the recipe? Let's find out. Well, that would be a combination of both the brown and white sugar on this one. So we're going to need to add those two together. So brown sugar here is at 6 3/8 cups. And the white sugar there is at 5 4/5 cups. And yeah, we need to add this together to figure out how much total sugar is needed in this recipe. So I'm going to first change these into a improper fractions, okay? And again, I'm going to, whatever I get from this, um, I'm going to write the answer as a mixed number in the end, okay? So cycle method first, right, on the 6 3/8. Let's go and do that. Change our mixed number into an improper fraction. So that's 6 times 8, which is 48. And then add the numerator 3, make that be 51. I skipped a couple steps there, but trying to save a little bit of time. The denominator stays the same as 8. But now we need to perform cycle method on the 5 4/5. So the denominator won't change in the fraction, so it'll still be a 5 there. But let's go ahead and multiply first with the cycle method. 5 times 5 is 25. Add the 4 numerator, which is 29. So that's 29/5 there. The denominators do not match, which we need in order to add the two fractions together. So we're going to have to force them to be the same. And I'm just going to multiply the denominators by the other fractions, which if you made a list, you'd find it's the same value. So I am kind of taking what I feel like is a shorter method right now, just to save us some time on this review. So I'd say, well, 8 times 5 and then 51 times 5 there. So 8 times 5 is 40. 51 times 5 will show that stack multiplication. 1 times 5 is 5. 5 times 5 is 25. So 255 40ths. And then the second fraction, we'll have to multiply these by 8. So 5 times 8 in the denominator is 40. Again, that forces them to match, which they should. And then I'll have to stack the multiplication for 29 times 8. 9 times 8 is 72. Carry the 7. 8 times 2 is 16, but add the 7 to the 16. And that would be 23. So 232 40ths is that second fraction. So a couple big numbers there, but it's still doable. And our denominator stays at 40. We're just going to add these two values together. 255 and 232. So let's go and stack these so that we can add them. Five plus 2 is 7. 5 plus 3 is 8. 2 plus 2 is 4. 487. And that gives us our new numerator. 487. And like I said, I mean, this is a word problem, so we do need a label. But we need this to be as a mixed number, our answer. That's what we want. So I'm going to set the fraction up. Oh yeah, this is, looks like 487 is not simplifiable because it's not divisible by 2, but 40 is. It's not divisible by 5 either, so that kind of ends it right there. So that should be pretty well simplified, although we'll still check our fraction of the mixed number just to make sure. All right, so let's look at 487 divided by 40. All right, multiples of 40. Let's go and list some of these. 40, 80, 120, 160. And yeah, I'm not showing the addition on that because we're trying to save some time. 4 won't go into 4, but it will go into 48 once. 1 times 4 is 40. So when I subtract that, I get 8, drop to 7. 40 will go into 87 twice. 2 times 40 is 80, which we've shown there. So when I subtract this, this will give me the remainder. 7 minus 0 is 7. 8 minus 8, that's going to zero out the tens place value there. So our quotient is 12, so that's the whole number and the mixed number, and the remainder 7 is the numerator of the fraction. Last thing we want on this one is the label, because this is a word problem, and looks like we're looking at cups. Again, if you want to be more specific and say cups of sugar, that's fine, but it's more work than I'm going to do on this. Jen went on a 2-day, 50-mile trip. The first day she biked 17 3/8 miles. How many miles did she bike on the second day? Good question. We're going to go ahead and figure that out. Okay. Now, the whole trip, like it says here, is 50 miles. That's 2 days, by the way. And now on one of the days, it's 17 3/8. If I want to find how many miles she goes on the second day, that's the difference between these two, difference being subtraction. So we're going to take the total amount of miles for the full trip, which is 50, and then how many miles she biked on the first day, which was 17 3/8. And I need to subtract these. Okay. In this specific order, by the way, because if you take 17 3/8 and subtract the 50, you'll get a negative number, which we should not be seeing yet. Okay. So the 50 is okay. I mean, we can write that as 50 over 1. It's not really a problem. But the 17 3/8, yeah, we don't want the mixed number to operate here. So 17 times 8, I don't know what that is, so I'm going to have to stack that. Multiply 17 times 8. 8 times 7 is 56. Carry the 5. 8 times 1 is 8, plus 5 is 13, so 136. And then finish off the cycle, add the 3 numerator. So that'd be 139 eighths as the second fraction. And because it's 50 over 1, of course, we're just going to multiply it by 8, the numerator and denominator there by 8. So just to save some time, I'm not going to show the stack multiplication, but 50 times 8, 8 times 5 is 40, and then I would just tack on that last 0. 1 times 8 is 8, of course, and then that second fraction stays the same as 139 eighths. So the denominators match, which we want. In order to perform our operation here in eighths, we are subtracting from 400, 139. So 400 minus 139, we'll stack that to do that subtraction. But we're still going to have an answer that's in eighths. So let's see, 400 minus 139. Got to borrow from our zeros here, so that goes all the way into the hundreds place value, right? 10 minus 9 is 1. 9 minus 3 is 6. 3 minus 1 is 2. 261. So I got 261 eighths. And 261 is not divisible by 2, which means we should be able to change this directly right now into a mixed number in eighths, by the way. So we just need to do the long division there. 261 divided by 8. 8's not too bad, so we can do that long division there. 8 will not go into 2, but it will go into 26 3 times. 3 times 8 is 24. When I subtract this, I get 2, but I need to drop the 1 to make that 21. 8 will go into 21 2 times. 2 times 8, 16. So when I subtract, this will give me my remainder. Make that 11 minus 6, which is 5. Remainder of 5. So the 32 is the whole value in our mixed number, 32. And the remainder of 5 is the numerator. So it's a 50-mile trip that Jen's going on here, 2 days. First day, 17 3/8 miles. She's way behind. So perhaps it's all down, most of it's downhill or something like that. But 32 5/8, once again, just make sure you're labeling your answers if you're doing it by hand. But that's correct right there. What is the perimeter of a triangle with sides 5 2/7 centimeters and 6 3/4 centimeters and 8 centimeters? Well, remember there's a triangle, so all we need is the 3 sides. Since we're looking at perimeter, we need to add all 3 sides together. Yeah, so we're just going to take these 3 numbers and add them together. So I'm going to show the 8 as 8 over 1. Now, we did a problem like this, seems like last time. And when we did, remember, well, this isn't a formality yet. It will be. I'm not going to really operate with that 8 over 1 yet. I just want to operate first with the 5 2/7 and the 6 3/4. Once I get those two simplified, then I'll be looking to add whatever that result is with the 8 over 1 there. So these two are still going to be fractioned in as sevenths and fourths. But we got to use cycle method to find their numerators. So 5 times 7 here first, which is 35. Add the 2 to make that 37. So that's 37 sevenths first. And then 6 3/4. 6 times 4 is 24. Then add the 3 numerator there is 27. So that'd be 27 fourths. Now, again, it's showing that plus 8 over 1, but I'm not concerned about that yet. I just want to be able to add 37 sevenths and 27 fourths first. Okay? So I'm going to do that work below. I hope that's okay. Let's see if I can find a way. There we go. Let's do that down here. But I need, before I can add these two together, I need the denominators to be the same. So I'm going to multiply them by each other. Just, again, it's kind of the quick method for now. So that's a 7 times 4 and 37 times 4, which will give us new numerators here. And denominators, and the denominators should match. 4 times 7 is 28. We have to stack the 37 times 4, though. 7 times 4 is 28. Carry the 2. 4 times 3 is 12, plus the 2 is 14. So 148 28ths. And then the 27 fourths, yeah, we'll multiply these two by 7. So 7 times 4 is 28. So again, that accomplishes our first goal to get those denominators to match. But I don't know what 27 times 7 is. Let's find out. 7 times 7 is 49. Carry the 4. 7 times 2 is 14, but add the 4 makes it 18. 189. So 189 28ths. Let's go ahead and add the two numerators together. Of course, the denominator will stay the same as 28ths. Let's see what we get when we add these together. 148 plus 189. So 8 plus 9, 17. Carry the 1. 1 plus 4 is 5. Plus 8 is 13. Carry that 1. 1 plus 1 plus 1 is 3. So 337, well, it will be 337 28ths. There we go. So I would look at this and see, well, can that be simplified? 28 is divisible by 7, but is 337? No. Nope. 20 is divisible by 2, but 337 is not. So there goes that one. And it's not divisible by 7. So yeah, that looks like it's as simplified as we can get that. So we're going to write it in as the sum of those first two fractions above now. So we're going back to our original problem up here. I haven't done anything to the 8 over 1 yet, right? So I'm still adding 8 over 1, but I need this other fraction that we have there is the 337 28ths. Okay, and now I'll start looking to combine that with the 8 over 1. Well, I need, again, it's still addition, so I need the denominators to match. Of course, I'm not going to do anything to that first fraction because that second denominator is just 1. So it's still 337 28ths in that first fraction. But we'll definitely scale the second fraction. Looks like by 28, by the way. So multiply 1 by 28. It gives us matching denominators of 28, but I got to multiply it in the numerator as well. Let's see what we get from that. 28 times 8. 8 times 8 is 64. Carry the 6. 8 times 2 is 16, but plus 6 makes that 22. So 224 28ths. Looks like we'll end up with a fairly big number here. And 28ths. Add it together. 337 plus 224. So let's go and stack these and add them. So I got 7 plus 4 is 11. Carry the 1. 1 plus 3 is 4. Plus 2 is 6. 3 plus 2 is 5. 561. Still in 28ths, by the way. But now we got a new numerator, 561. And let's see, 561, is that divisible by 7? No, it's not divisible by 2 or 4 either. So that should be simplified. It's just we need this as a mixed number. Okay, so let's go ahead and look at this with some long division. 561 divided by 28. Now I don't have my 28 multiplication tables down. We're going to have to look at that. Let's see, 28. I'll do a different color. 20, there's our first multiple. That's another 28, 56. There's our second multiple, 28, 14, 84. Another 28. We'll stop there and see if that's enough. So that's 112. All right, let's see how we did. Okay, so 28, it will go into 56. Oh, exactly twice. Guess I could have stopped there. 2 times 28 is 56. So when I subtract that, it zeroes those out. I'll drop the 1. Well, 28 will not go into 1. It goes into 1 0 times, which means the 1 here is actually our remainder for the mixed number, right? So we got the mixed number is still in 28ths. The quotient there is 20, so there's a 20 there, but the remainder is 1, so 20 and 1/28. Just going back to the label on this, though, it looks like it was centimeters that this circle was being measured by, so we'll keep it in centimeters. There we go. Ron is making a display board for the school trip. The board is 10 2/3 feet by 6 feet rectangle. He needs to add the ribbon border around the entire board. What is the length of the ribbon that he needs? So this is a perimeter problem because it's the amount of ribbon that's going all the way around the board. So let's see. Now we're going to take these two values. Let's see if I can technify this. 10 2/3 and 6, right? Those are our two measurements. Now, this is only length and width right now. Since that's the case, we're going to need to add these two together, right? But not only that, but to go all the way around the rectangle means that we're going to have to duplicate these. There we go. So this is our full problem here. We got the 10 2/3 plus the 6. That's only 2 of the sides. But since it's a rectangle, we got to add those two sides together again. Now, of course, some of you would prefer just multiply the 10 2/3 plus 6 times 2. It's the same thing. You'll get the same answer either way. But since we're in the unit where we're just adding fractions and mixed numbers, this is what I'm going to do. Okay. Now, on the previous problem, we only focused on 2 of these at a time. That's because, well, I think it's going to simplify it. So I'm going to show this as 6 over 1. And there's a nifty shortcut here, but I'm going to pretend like we don't know what that shortcut is, because especially since we haven't done all of it yet. So I'm going to focus on the 10 2/3 plus 6 over 1. And whatever I get out of this, we'll simplify that problem. Now, I'm going to change these into improper fractions. Of course, 6 over 1 is already an improper fraction. But the 10 2/3 needs to be an improper fraction. So the denominator will not change. It's still thirds. Applying our cycle method to that, though, would be 10 times 3, which is 30. And then add the 2 numerator to make that 32. So 32 thirds plus 6/1. Of course, we need the denominators to match. So since that second denominator is just a 1, I can scale it pretty quickly, which means I do not need to change the first fraction. It's still 32 thirds. But the second fraction, yeah, the 1 I need to multiply it by 3 in the denominator to make it a matching 3 denominator. And then the numerator is 6 times 3 as well. Again, doing that in both the numerator and denominator guarantees that we come out with the same value. So we need to add these two numbers together. Still dealing with thirds here, but 32 of these plus 18 of them. So it's a little bit better about time right now. So let's go and stack and add these. 10 and 5. So that ends up being 50 thirds. But now, oh yeah. So at this point, we'd say, and be careful. I almost thought, well, we need to change that into a mixed number. But again, that only guarantees the first two parts of this, right? The 10 and 2/3 plus the 6/1. What we did right there was just this part of the problem, which means that we just changed that into 50 thirds, right? Now that means also that this other 10 and 2/3 plus 6 would also be another 50 thirds. Right there, we just need to add these two values together, and that kind of forces the denominators to match. So where before, I think in the lesson for a problem like this one, I said, hey, just keep adding these two at a time, which you can do, by the way. But if you notice that these two match and these two match, then you're going to get the same improper fraction either way. So that's how I'm going to proceed. Again, it doesn't matter which method you use. The answer should be the same no matter what. So we're going to add those two 50s in the numerator together. That's 50 and 50. And that's still in thirds, but now we're looking at 100 thirds. And yeah, now it's at this point that we would want the mixed number because the problem started with a mixed number. So that's 100 divided by 3. 3 won't go to 1, but it will go into 10 3 times. 3 times 3 is 9. Subtract the get 1, drop the 0 to make that 10. 3 goes into 10, well, 3 times. 3 times 3 is 9, so when we subtract this, will give us our remainder of 1. So, our final mixed number here in thirds, there we go. Of course, the quotient is 33, so 33 and a remainder of 1, 33 and 1/3. Now, the last thing on this is that we should have some kind of label with this, so I'm going to need a little bit more space there. Let's go ahead and tack that on there. Of course, we were dealing with feet before, which means we should still be dealing with feet. 33 and 1/3 feet. There we go. Here's a good one to simplify. It's got three fractions that we got to add. And, well, you could make lists of all these, and in fact, you could work with these. Well, that's actually a good idea to work with these two at a time. Now, just a quick view of this problem, just to start out with, okay, is that we should notice that while 9 is not a multiple of 6, 18 is a multiple of 9 and 6. So if you saw that right away, you could say, well, I'm going to change all three denominators into 18 and just add the numerators, which you could do, all three at one time. But like I said before, generally speaking, it's good practice just to focus on two of these at a time. So I would say, well, look at this 1/6 and the 2/9. Let's add those together and see what we get. Okay, that's going to give us a fraction here. And then whatever we get from that, then we can add the 18. Okay, so that'd be 5/18 right there. Okay, so whatever I get from these two added together, that's what I'm gonna put into this fraction here. Okay, now I know 18 is a common multiple of both of these, so listing multiples would be a good strategy here. So right, 6, 12, 18, and then 9 is just 9, 18. So to change these two fractions so that they have the common denominators, I know the denominators should be 18, particularly 6 times 3 would be the first denominator of 18. So I'd have to scale the numerator as well. 3 times 1 is 3. The second fraction, I can see 18 is the second multiple of 9. That would give us matching denominators of 18, but I got to scale the numerator by the same value, 4. Yeah, we can add these two numerators together, 3 and 4. So in 18th, That would be 7/18. And that cannot be simplified, which means up here we can put in the 7/18. All right, and just by doing that, it shows that the denominators would match. So we have 7/18 plus 5/18. So let's go and add those two numerators together. Of course, the denominator stays the same as 18, but 7 plus 5. And that's not hard to do. Still an 18th, by the way, but 7 plus 5 is going to give us 12. And yeah, 12/18. That's a proper fraction. It's just not fully simplified. We got to simplify these both. I see they're both divisible not only by 2, but 3 as well, which means they're actually both divisible by 6. Yeah, these are low enough. Hopefully you saw that as well, that both these will just be divisible by 6. But if not, you should end up with the same answer either way. 12 divided by 6 is 2. 18 divided by 6 is 3. And yeah, that's about as simplified as we can make this proper fraction. All right, so find the perimeter here, and it's important to remember that the opposite side lengths are going to match opposite side lengths. So left matches right, top matches bottom. And the first thing that I would want to do on this problem is to change the 3 3/4 and the 7 1/2 into improper fractions so we can work with them separately. So I'd say I'm going to start with the 7 1/2. Doesn't matter if you start with that one or the 3 3/4 first. But I'd say, okay, cycle method, 7 times 2 is 14. Add the one numerator, 4 plus 1 is 5, 15, boom. So that is the same as 15 halves feet. I don't really need to worry about the label right now because we're going to be changing that or operating with it later on. So cycle method on 3 3/4. That'd be 3 times 4, which is 12, plus 3, boom, 15, 15/4 from the 3 3/4. Okay, so that means all these opposite sides have the same exact measurements. So this one here is 15/2 feet, and then this one over here at the bottom is 15/4 feet. And we need to take all 4 of those values and add them together. Maybe I should have given more space, but I can work from the bottom, perhaps. So let's see, we got 15/2. I'll start from the left and work my way clockwise, and then 15/4. These are being added together, and we'll add them together again. So it's a little technological shortcut. Boom, there we go. So that's all 4 sides added together. Now, when we did this in class, we just said, hey, focus on these first 2 together, and then of course, once we get that, then we can change these. In fact, I might do this with a slightly different process this time. I hope that's okay. But no matter which method you use, you should get the same answer no matter what. Okay. So what I'm going to do here is I'm going to first operate with 15 halves, and then I'm going to add that to the 15/4. Okay. And let's simplify that just to see what we get first. Okay. So I'll work with that below. And since we're adding these 2 fractions together, we're going to need to have the denominators be common. And just as a quick shortcut on this one, just because we are a little pressed for time today, but that's all right. I'm going to say, well, I'm going to multiply the 2 by 2 because I know 4 is a quick multiple of 2. So that'd be 2 times 2 gives me a new denominator of 4. But I have to multiply the 15 by 2 as well, which is, again, just a little quick math on that, 30. So I have 30/4, and then the 15/4, of course, that did not change. So it's still 15/4 there, but now the denominators match, and so we're going to deal with this in fourths, adding together the 30 and 15 numerators, which then still becomes fourths, but now we're looking at 45 of those fourths. Now, why did I do that? It's because I was looking to simplify not only these 2 fractions here, which now show as 45/4, but this set also is 45/4, so I don't need to simplify that as well. In fact, by doing this way, it forces the denominators to be the same, so 45/4. And so, yeah, the denominators do match. So we're dealing in fourths here, where we're going to take 45 and add 45. And again, just because for the sake of time today, so a little quick math on that is 45 plus 45 is 90. Now, if you see problems like this on the quiz, it's going to want the answers written as mixed numbers. So let's go ahead and just change our 94th into a mixed number, whatever that is. The denominator will still be fourths, so let's put that in there. That's fourths for now. We'll label it later. Let's do the long division now. So that's 90 divided by 4. 90 divided by 4. Well, 4 will go into 9 2 times. 2 times 4 is 8. Subtract to get 1, drop the 0 to make that 10. And 4 will go into 10 2 times again. 2 times 4 is 8. When I subtract this, the remainder is 2, which means it's the numerator of that fraction. Oh, I skipped a step there. I probably should have simplified the 94th, but I didn't. And that's okay. I guess this is kind of a good example to see that on. The 22 and 2/4 is the mixed number, but the 2/4 can be simplified. So I should simplify it. Of course, it's not going to affect the whole value here. It's still going to be 22. I just got to simplify the 2/4 there. So divide these by 2. It's not even difficult math there. It's just forgot to do it. 4 divided by 2 is 2. 2 divided by 2 is 1. So it ends up being 22 1/2. Last thing we need on this is just label in feet. So this would be the perimeter all the way around our rectangle there.